Hello everyone, welcome back to my YouTube channel. Okay, so today we'll be looking at chemistry and we'll be dealing with the topic that is known as matter and separation techniques. What is matter? Matter can be defined as anything in the universe that has a mass and occupies space. Everything you see around you is matter. For example, a person as me, I have mass, which is known as the quantity of matter, how much matter you have, and I also occupy space. I believe you understand. Now, matter is the basis of study for all science. Chemistry studies matter, its compositions, the forces that hold its structures together, and everything about matter. Physics also studies matter, nature, and energy. Also, chemistry studies a specific form of matter which is known as living things or life, and it comprises of plants and animals. Plants and animals are matter which have life in them. Okay, however, chemistry is concerned with the nature of matter, the structure of matter, the chemical composition of matter. So, matter can be classified into two forms, which are pure substances and impure substances, otherwise known as mixtures. Matter based on chemistry or chemical composition can be classified into two forms, which are pure substances and impure substances, otherwise known as mixtures. Under pure substances, we have what we know as elements and compounds. Elements and compounds. While under impure substances, we have heterogeneous mixtures and homogeneous mixtures. Mixtures. This is the classification of matter based on chemical composition, based on its chemical properties. Now we also have the classification of matter based on its physical properties, and that is concerned with the state of matter. The state of matter or the form in which matter exists, which is solid, liquid, and the gaseous state. I believe you understand. Now let's go into each forms of matter by defining them and understanding them. The first one, pure substances. What do we understand as pure substances? Pure substances are substances that have definite or fixed compositions as well as distinct properties. Pure substances are substances that have definite composition and distinct properties or their intrinsic properties. Why do we refer to their properties as intrinsic properties? These are because these properties are only special to them alone. They only have the properties. For example, let's look at a compound such as H2O, water. Water has definite composition, right? The elements which make up water are hydrogen and oxygen, and they are combined in the ratio 2:1. Anywhere you go, water is always according to this formula. There is no water such as H3O. they always have the same definite composition, in which hydrogen is 2, oxygen is 1. This is what we mean by definite composition. Now, distinct properties. Water can react with metals to give their corresponding alkalis and hydrogen gas. For example, let's look at an equation as this. Sodium metal plus water, which is in its liquid state, combining to give us sodium hydroxide plus hydrogen gas. Now let's check if this equation is balanced. On the left hand side, we have one sodium. Here also we have one sodium. That means sodium is balanced. Here we have one hydrogen. Here also we have one hydrogen. That means hydrogen is balanced. But when we look at, that means we have oxygen is balanced. When we look at hydrogen, here we have 2 atoms of hydrogen, and on this side we have 3 atoms of hydrogen. This is not balanced. We have to balance it. And how do we balance it? Here we have 2 atoms of hydrogen, here we have 3 atoms of hydrogen. We have to introduce 2 here, and that makes it 4 atoms of hydrogen when we say 2 times 2. So since we have 4 atoms of hydrogen here, it's still not balanced. When we say 4 here and we have 3 here, it's still not balanced. So what do? If we are to introduce 2, if we are to introduce 2 here, this will give us 2 atoms of hydrogen and 2 atoms of hydrogen, making 4. So this equation is balanced. This is the correct equation for the reaction of sodium metal and water, giving us its corresponding alkali, which is sodium hydroxide and hydrogen gas. So this is what we mean by definite composition and distinct properties of pure substances. Now we have 2 types of pure substances, which are elements and compounds. Elements are pure substances which consist of only one type of atom. That is, their atom is only of one type. For example, let's look at an element such as hydrogen. Hydrogen always exists in its gaseous state as a non-metal. Even though it consists of 2 atoms, they are still of the same type of atom. Why? Because if you look at it, here we have 2. So that means we have 2 hydrogen coming together. They still have the same type of atom. They are still composed of the same type of things, but they join together to form a molecule. I believe you understand. Now, it is important to know that an element into cannot be split or broken down by an ordinary chemical process. I believe you understand. Except in cases like nuclear or radioactive energy. I believe you understand. Where we have uranium being broken down. But aside from nuclear reactions, we cannot break down an element by an ordinary chemical process. Now let's move on to compounds. Compounds are a chemical composition of 2 types of elements. I believe you understand. Compounds are a chemical composition of 2 types of elements coming together. They are a composition of 2 or more elements being chemically combined together. It is very important to note that they also have definite composition and distinct properties, which are the features of pure substance. They are also pure substances, but in this case, they can be broken down by chemical processes, such as thermal decomposition. What do we mean by thermal decomposition? This is the breaking down of compounds using heat. For example, lead two nitrates can be broken down into using heat into two molecules of lead or 2 moles of lead plus nit- nitric oxide. I believe you understand. So compounds can be broken down. And it's important to note that they also have definite composition and distinct properties, just like in the case of water, which we explained earlier. Now let's go to the impure substances or mixtures. Impure substances or mixtures are composition of two or more types of substances that are physically combined together. In the case of compounds, they are chemically combined together by chemical reactions and chemical changes. Now let's go back to the compounds. The composition of compounds are elements, right, that are chemically combined together. But it's important to note that compounds have their distinct properties apart from the elements they are composed of. I believe you understand. Let's look at sodium and chlorine, for example. This is sodium, which is in solid form, and chlorine, which is in gaseous state, and they give us sodium chloride, which is can be in aqueous form or can still be in solid form. Aqueous form is the solution, while the solid form is what it is normally composed of. When we have water, it's now a mixture. Sodium chloride has its own properties different from sodium and chlorine. Is now a new compound or a new substance by itself, and it has different composition. It has the same composition made up of sodium and chlorine, but it has different properties aside from sodium and chlorine. Why? Because this substance can react with many substances on its own type of reactions, but it does not react such as like sodium and chlorine. I believe you understand. Now, mixtures. Mixtures always have the properties that are made up of their um mixtures always have the same properties as their constituent composition. For example, if we have a mixture of salt and water, whenever we whenever we look at them, we see that mixtures always have the same properties. Salt and water, they combine to give us a saline solution, and we see that salt water is different from fresh water by its density. Salt water is more dense than fresh water, right? So the mixtures, they now have their properties from the sum total of the individual constituents of which they are made up of. So that's the difference between compounds and mixtures. Now let's look at the type of mixtures: heterogeneous and homogeneous mixtures. Let's look at homogeneous mixtures. Homogeneous mixtures are mixtures that are that have uniform composition, and also they are not visibly distinguishable. What do I mean by that? Let's look at a mixture of salt and water. Salt and water is a saline solution. You cannot easily see salt because it is dissolved in water. You cannot see the particles of salt. That's what we mean by true solution. True solution. True solution can also be known as homogeneous mixtures in the case of salt and water. Why? Because the particles are not easily distinguishable. You can't see them with your naked eyes, right? Because they are true solution. And if we are separate them by filtration method, which we'll still explain, they cannot be separated because they are already evenly dispersed in each other. I believe you understand. Let's look at heterogeneous mixtures. Heterogeneous mixtures are mixtures that don't have uniform composition. For example, sand and water. You can easily distinguish between sand and water when they are in a mixture, and they don't have uniform composition, as well as they don't have the same intrinsic properties. You can always differentiate between them. I believe you understand. This will be the end of our class. I will continue looking at separation techniques in the next class. Thank you.